The biomechanical goal of a sprint start is to achieve maximal acceleration in the shortest time while keeping optimal body mechanics. This is shown in the deterministic model where we're starting with the acceleration of a sprint start and the horizontal forces, which then goes on to force and mass, where the increased force increases acceleration but increased mass decreases acceleration. Then focusing on force, that's divided by the initial position and ground force reaction, where the initial position includes the block setup, which the angle of the blocks and the position are crucial, and athletes often adjust their block setting based on their mechanics and their preferred starting position. And the athlete's center of mass is positioned forwards with a low torso to optimize the angle of force application, which then shows that going off initial position is the center of mass and knee positioning, where knee position is focusing on the angles. And then going from that is angular acceleration. Going back to force, that goes off to ground reaction force, which is when the athlete pushes against the blocks, the force exerted against the ground is crucial, which then goes on to block force and the block time, and then the impulse momentum relationship. The critical features of an effective block start involve optimizing body position, block spacing, and the angle to enhance body mechanics for a powerful push-off. Research suggests that the median block spacing is usually optimal, with the front and rear knee angles in set position around 90 and 30 degrees respectively, and hip positioned moderately high. This crouch stance is supported by the high explosive strength of elite sprinters, allowing them to generate significant force in the blocks while minimizing the horizontal distance from their center of mass. Furthermore, sprinters typically adopt their preferred right and left leg placements in the blocks while adjusting their anterior-posterior spacing of the front block relative to the starting line and the degree of forward lean in the set position, which is usually 20 to 30 degrees. Studies have explored 4 block configurations featuring combinations of 2 arm orientations, forward lean and perpendicular to the ground, and the 2 distances from the front block to the starting line, which is bunched and elongated. The ideal body position for a block sprint start is important to ensure that the center of mass starts close to the line and ground during the set position. Research shows that the crouched position allows them to produce high explosive force. When observing the performance and taking the videos, there are a few important considerations. These include bright lighting so the video is clear, contrast between the person, specifically their clothing, and the background so they are visible, bright markers on the athlete's joints so it's easy to see these joints and make clear notes in Canovia, for example. Record in slow motion so there's more frames per second. The participant had to have reference of the skill, so therefore watching the video and understanding how to do the skill, and the camera being stable on a tripod and specifically 90 degrees from the ground, and a scaling object. When editing the footage on Canovia, you can see that the position of the athlete is forward, their torso is forward, and having their center of mass somewhat close to the line, but in regards to the literature, it should be closer. And on the second image, it's showing that the center of mass is moving relatively horizontal rather than upwards. These 2 images show the knee angles of the athlete, where their rear knee angle was 145.9 degrees and their front knee angle was 111.9 degrees, which differs from the literature, which says the best outcomes come from 130 degrees and 90 degrees. Looking at this image, it shows that the athlete's body position, their torso was 37.1 degrees, when literature suggests that 30 degrees is optimal. Whilst this isn't big of a difference, it could be enough to show that their skill was not optimal in comparison to the literature. Focusing on the body position, especially from those photos before, the degrees were quite different from those mentioned in literature, which were the best for this skill, the biomechanics of this skill. And this could explain why the center of mass was not close to the start line, which literature again suggests. So this could be the result of the body angles not being as correct in comparison to the literature. But in regards to the center of mass, it does travel quite horizontal, which was suggested by literature. Focusing on the body position, especially from those photos before, the degrees were quite different from those mentioned in literature, which were the best for this skill, the biomechanics of this skill. And this could explain why the center of mass was not close to the start line, which literature again suggests. So this could be the result of the body angles not being as correct in comparison to the literature. But in regards to the center of mass, it does travel quite horizontal, which was suggested by literature.